Okay, now, in the previous tutorial, we had the chance to see what do we mean by including an interaction terms in the linear or nonlinear regression model that we have. And we have now a kind of an intuition how to interpret the inclusion of an interaction terms which is essentially there are two features that they all simultaneously have an impact on our response variable. Now we just want to do the same thing as with some real data sets in the real environment, which is going to be the R. But before to do that, we just need to install a package which it allows us to visualize the impact of the interaction on the response variable with respect to the two features that they are interacting with each other. I'm just going to go ahead, as you know, with the typical command to install the package, which is going to be the install packages, and I have the quotation mark, and I just put the name of the package that we need, which is going to be the effect package, and I'm just going to execute that by pressing Control Enter, and it takes a couple of seconds that the package is going to be installed, and just we call it by the library to see that. I'm just going to also go to the package tab to make sure that after the installation we see the package which is going to appear here. It's going to be the effect. I just go down, scroll down, I just go to the E, and you see that okay, we have the effects. And now the other thing which I just want to do, we just want to, I should say, install I had to just put the effects. That's there should be an S at the end. I'm just going to reinstall that package, and let's see, I saw the effects is there, and it says that the package effects successfully unpacked, and as you saw that also before, you should see the package effects, which it should appear there. I'm just going to scroll it a little bit down, and you see the effects, which is the effect displays for linear, generalized linear, and other models. And also, in order to have it running inside, I should say, the R, I'm just going to use the library command with the name of the package which I already installed, which is going to be the effects. Execute that by the Control Enter, and we see that the effects package, it has a tick next to that on the left side, which means that this package is ready to be used in our model. Okay. Now, the thing that we just wanted to do, for this example, we are just going to do, I should say, a non-Bayesian regression analysis to show the impacts of the interaction terms. And on the next tutorial, we are just going to run the same thing in the Bayesian context. Then we just run the model comparisons on the next tutorials to see that which model is the best one. The model which has the interaction terms, or the model which exclude the interaction terms between the features there. Okay. And now, in order to do that, I just need to also to upload the data sets which I need for this analysis. I decided to just use the data which is already in, I should say, it's an internal data set with the R, which is going to be the empty cars, which, as you saw that here, it's the data was extracted from, I should say, a magazine, and it has, I should say, some features and some relevant features that it's easy to show, I should say, the interaction terms in that data set. Then I'm just going to execute that line, pressing Control Enter, and you should see, I should say, the empty data cars. If you scroll it a little bit up, you should see that data sets, which should be there. There it is. We see the values, we have the empty cars. We can just press on the promise and we see the empty cars. It shows that it is a 32 observation of 11 variables. In order to show, I should say, these data sets and investigate that more closely, I'm just going to put, for example, the class of the empty cars. You see that it's a data frame. The dimension that we saw that is 32 observations by 11, I should say. The features. We can just also check the head of the data sets to see what the data includes. I'm just going to with the empty cars, and I'm just going to see the 5 first rows of the data, execute the line, and you will see that, I should say, we have, for example, the different vehicles, the Mazda RX-4, we have, for example, the Mazda RX-4, and we have Datsun, and many other different cars. We have the features, and also we can also go for the summary of the empty cars. And if you execute that, you see, for example, for each features, what do they have? And also, for example, if you just want to see that, for example, on different features that we have MPG, which stands for mile per gallon. We have the cyber wall, this is a cylinder, and also the things that we need to work with, this is going to be the HP, which is horsepower, and also WT, which is going to be the weight. And it's also the gear and many other features that we do not just want to work with those features. If you just want to just get more, I should say, understanding of these type of data sets, I recommend you just search it online, and you see in the R, the data has been extensively explained at what each feature represents. And now, we just want to just go ahead to just first make our first model. For the model that we have, we can just, the thing that we have seen, we come here with the model. I just, as we said, that we are just going to go ahead with the nonlinear model. I'm just going to go ahead with the generalized linear models. You see that first of all, we have to just associate with the formula. The formula that we have, we intend to have some predictive model which it functions the mileage per gallons of each cars that we have, of 32 cars that we have in our data sets, as a function of the horsepower of the car, and also I'm just going to put that the weight of the car. It's going to be the first one. Also, the other thing which is essential to just put that in our model is going to be, let's say, the data, which is going to comes from the empty cars. And before we just execute that model, I'm just going to go ahead. I call it the model. No interaction. It means I store that into an object which is called model, no interaction. And I'm just going to execute that line by pressing Control Enter, and the model is stored there. Model no interaction. It's a list of 30 objects, and we can see that what's the class of the things that we have created. It's going to be the model no interactions. If you run it, you see that it's a kind of the linear model class. And also we can just go ahead to just have a summary. That's the thing that normally what we have done. And we just put the name of the class, the objects that we have created, which is the model no interaction. Execute that line, and you will see that what do we have here. You see that here we have, for example, the intercepts. We have some inferences for the intercepts, the coefficients for, I should say, for the slope for the horsepower, and also we have the coefficients for the weight. And we see that these coefficients are essentially, although that they comes with the p-value which is less than 5%, which shows that they are significant in our model, we see that they come, I should say, the slope is going to be minus. It means that the lower weight the car has, then we should expect to see the lower, I should say, the lower it has, I should say, the interpretation, the mileage per hours we can get, I should say, have more mileage per gallon. Then it's very reasonable that the car that you have, if it has less weight, then it means that your car is capable of having a higher mileage per gallon, I should say, as a fuel which it consumes. Okay, this one, it was a kind of, I should say, a reminding you of the things that we have done so far. Then we have no interaction terms. Okay, let me just come here. I say with no interaction terms. And also, on the other line, I'm just going to come here. I set the with interaction term. With interaction terms, let's see what happens then. I just go ahead. I'm just going to go ahead again with the same model that we had GLM. We just go ahead with the formula as what we had. I'm just going to go ahead with the same formula that we just modeled the mileage per gallon as a function of horsepower and also the weight of the car and also the interaction terms between, I should say, the horsepower and also the weight of the car. And that's how we show that interaction terms by double columns there. And also we know that the data, again, it comes from the empty cars data that we have. And I'm just going to store all the object into a term which is going to be called model with interaction. Execute the line by pressing Control and Enter. And now I'm just going to go ahead to have a summary of the statistics that I have with this model, which is going to be the model with interaction terms. Execute that line and we will see that what happens there. Okay. We see that when we run the summary analysis, we have, first of all, we have the call that what is the model that we created. It shows that this is a formula which we try to have, I should say, a model which predicts or models the miles per gallon of horsepower, weight, and interaction between the horsepower and the weight. And the data that uses the empty cars. Now here, we just come here see that for the intercepts and also the slopes that we have for, let's say, the horsepower, weights, and the interaction terms, we have these values there. And also we see that for the p-value for all of these terms, for the intercepts, for the horsepower, for the weight, and also the interaction terms of the horsepower and the weight, we have all of them significant because they have all 3 stars next to them. And now, in order to, I should say, we do not just work right now with the other aspects of the model, which shows that, for example, alkyl, I should say, information criteria. That's not the thing that we just want to just work with now with it. But we just want to see, I should say, the impact of the interactions terms and try to visualize it. You see that even if you put the interaction terms, you get that it's going to be a significant term in the model that you have. But let's now to visualize this one and see that what do we mean by the interaction terms when it's included into our model then. Visualization of the interaction term. Okay, and now, in order to see the visualization of the interaction terms, let's go ahead and use a library that we have used before. In order to just show the interaction effects, I'm just going to use, I should say, the function which is going to be the effect, which we used that before. I'm just going to press F1 to see what other options that we have to just put inside the model that we have. For example, you see that we should have some critical values which we have to include. It's going to be the term, it's going to be the mode, and also it's going to be the covariance functions for this model. In order to include these terms over here, I'm just going to go ahead, first of all, just go ahead for the term that we have. The term that we have is going to be the interaction terms. The interaction terms is going to be the interactions of the horsepower with the weight of those cars. That's going to be the thing that I need to include in my model first. The other thing which I need to just include in my model is going to be the name of the model that I use to feed these models, which is going to be the model with interaction term. And also, the other things, arguments which I have to just put into my model is going to be, I should say, for example, the mode of the things which I just need to include. In order to just put the model, I'm just going to create a list. And in the list which I'm just going to create, I'm just going to go ahead with the weight. I'm just going to show the impacts of the weight on, I should say, the horsepower, which has an impact on, I should say, the mileage per gallon. Then that's why I just go ahead with the weight. I can come here with some random numbers to just create the list which I'm going to have here. I said that for the weight, it's going to be a combination of any values which you want. But in order to just have some kind of, I should say, realistic values, I'm just going to use the mean of the weight of the, I should say, the empty cars which I had. We see that the mean of the weight, as I'm just getting here, is going to be 3.5. 2. And also, I'm just going to just put one standard deviation away and above from that one. In order to just find the standard deviation, I just go ahead with the same command, which is going to be empty cars, but I just go with the weight, execute the line, which is going to be almost 1. Then I just go ahead with, I should say, 2.21 and also 4.21, which is an approximate of one standard deviation away from the mean which we had from this command, mean of empty cars $empty. And also, the other thing which we have to just include, okay, let me see that if, okay, now the thing is that we have been able to just do that one, and now it seems that the effect is going to be done. Also, the other thing which we need to do is that, as you see that I had to just put the covariance matrix vcov dot equals to the vcov, and now I'm just gonna go execute the line, and you see that I have, I should say, the effects, which it shows that, for example, at these values of the heights, what is the corresponding value of the horsepower. But the thing that we just want to do, we come here to plot. This is the effect model which we had on, I should say, are the model that we had. You see that the plot is going to be something like that. However, I'm just going to add another line, which is going to be essentially, I saw that it's going to be a multi-line. We have everything inside one plot. Multi-line, I put that should be equal to true, and I'm just going to go ahead and execute that code, and you see that the effect of the interaction term is now just within one single shot of the plot that we expected to have. I'm going to zoom on this in order to explain what has happened there. And now in this, let's interpret how can we just see the results of the interaction on the mileage per gallon with respect to two covariates or two features of the horsepower of the car and the weight of the car. You see that on the vertical line, we have the MPG, which stands for the mileage per gallon. That's our response value, which we modeled that. And also on the horizontal line, we see that it's going to be the horsepower. In the code that we started here, if you had started, let's say, with, for example, the horsepower, the HP, you could have done the same analysis to just have, let's say, a list of the mean and the standard deviation from, I should say, the horsepower. You could have seen, I should say, here the weight on the horizontal axis there. Now, you see that we have the mileage per gallon on the vertical axis, we have the horsepower on the horizontal axis, and we have three lines that each three lines, they are color coded with different colors. For example, you see that this is the name of the plot, this is the horsepower and weight interaction effect plot. We have, I should say, and the color coding, it has been demystified here, that the blue line, it shows the weight of the car with, I should say, with the mean of 3.21. That's what we got from the mean of the weights of the cars on the empty car datasets. The pink color of the line is going to be one standard deviation away to the left of the mean, which is 2.21. And the green line, which is going to be here, it shows that the line is for the weight car, which is one standard deviation away from to the right side of the mean, which is 4.21, if the mean is 3.21. Then we see that by this analysis, we see that if the horsepower, for example, it increases, when the weight, I should say, is either 3.21 or 2.21, the pink and the blue one, you see that when the horsepower increases, the mileage per gallon, I should say, it has a slope to decrease also, as what you can see. However, when the weight is going to be 4.21, you see that as the horsepower increases, as you walk on the x-axis going towards the right, and you see that the horsepower is being increased, you see that almost The mileage per gallon is a horizontal line, which it shows that the slope is going to be 0, which it means that if the weight of the car is going to be fixed at 4.21, then essentially, even if the horsepower increases, you do not have any changes on the mileage per gallon on the car, which is a very, I should say, interesting scientific, if we can call that, conclusions from our observation. We see that at this critical weight, which is going to be 4.21, regardless of how we just add the horsepower of the cars, we have not any tangible effect on the mileage per gallon of the car if we are looking into to increase, I should say, the efficiency, I should say, of the cars that they are being designed by the engineers, I should say, on those, I should say, car manufacturers. Then you see that by taking into the account the interaction terms between some features and also at the same time being able to visualize that interaction effect on the response variable of the model that you have designed, you can just come to a very good discovery of how, for example, as what we did here, that at one point there is one critical features that the other response variable, regardless of change of the other response, regardless of change of the other features, they are not going to change a lot. And that's a very cool knowledge discovery of the data sets that we have, and we were able only to do that by looking into the interaction terms between two or more features in our data sets. In the next tutorial, when we come back, we are just going to do the same thing in the Bayesian framework, and we should just want to be able also to just use some validation technique to compare the models with each other. See you on the next one.